And hello to everyone. Welcome in. It is 10:01 p.m. Central Time on Wednesday, July 6, 2016, and I've got you here on the Earthquake 3D live stream, where we do a daily update on the earthquakes that struck since yesterday at my update at 10 p.m., and we just recap everything that we've been watching for to occur. We watch for earthquakes to occur based upon the earthquake forecasts that are issued. And, of course, we have other people that are watching, and we know what to watch for, and that's the point of doing this live stream, is to teach everyone about seismic forecasting and also to document the earthquakes along the way. So right now we're looking at the last 24 hours of activity from the USGS, and this is showing us 0.0 and greater in the United States and 4.0 and greater internationally. And it looks kind of limited because it is. To get a better view, we have to combine the Europeans and a few other agencies to get an overall picture of what's going on around the world. Most of my viewers are in the United States, so we will address the US first, again, like we did last night. And if you may remember, last night we were talking about the 4.3 that struck off the coast and told you all to watch for new earthquakes to strike to the east-southeast, possibly larger earthquakes to strike to the east-southeast. And since then, a new swarm has broken out at Lassen Peak, Lassen Volcano in Northern California. And if you look where that lies in relation to where the 4.3 struck up to the north, and my mouse isn't going to match up for you guys because of the way this little smaller window is, I'm going to turn on the full screen view. We'll disappear the view count for a little bit just so you can get a better picture on the full screen. And when I zoom in on the area, hopefully you guys can now make this out a little bit better. In Northern California, we have a new swarm breaking out, and we haven't seen any swarms in this spot in the last month since we've been watching, at least month and a half since we've been watching this new development break out across California. And for longtime viewers, when I say Lassen Peak, you most likely already know what's there. But for new viewers, I'm going to take one of the larger earthquakes that struck, and we will pull the coordinates from the USGS. We will put these in on Google Earth and go see what's there. And for longtime viewers, you guys already know, so you won't be shocked. But when you see where the swarm is striking, I think it'll kind of stand out to you a little bit as interesting. Here is Lassen Peak itself, and it's striking directly on the side over one of the lava flows that exists off of Lassen. But the Lassen Volcanic Center is made up of hundreds of smaller volcanoes extending all the way to the east by over 100 miles. And then we have multiple other peaks that are a part of Lassen Volcanic Center. And this is Smithsonian marked. The red triangle is a place mark I can download, or you can download if you have Google Earth. And you can look and read up the information from the Smithsonian. I can just tell you, you don't see that screen, or maybe you do, but chances are, or let me see if you guys do see this screen. Well, I'll read the top portion of it to you. The Lassen Volcanic Center consists of the Anadesic Broke stratovolcano southwest of Lassen Peak, a dacitic lava dome field, and peripheral small anadesic shield volcanoes and large lava flows primarily on the central plateau northeast of Lassen Peak. Last eruption was 1914 to 1917. I thought it was 1904 to 1907, so I was off by 10 years. You read it a couple times. It's a long time ago. 100 years ago was the last time that this volcano erupted. So when we look at where the earthquake swarm is striking and then look at it in relation to where the earthquake struck up here off the coast of Oregon yesterday, the 4.3, and then you can begin to understand why the swarm struck here. The pressure is transferring to the east-southeast. This ties in with a question that was asked to me last night in the question and answer session after the live update, where a viewer asked me over on Facebook. I have a little question and answer section section set up for the session over on Facebook where people can ask me different questions. And a guy asked about frogs. He lives right north of Lake Tahoe, where you see these smaller earthquakes striking. And he said frogs were migrating from west to east, a large amount of them, and that was abnormal, according to the person that lives there. And he asked, what does that mean? Does it mean there could be a coming earthquake? Well, just to the northwest, I talked about it last night, that the earthquakes were progressing up towards Lassen, and to keep an eye on Lassen. Now Lassen struck by a fairly rare earthquake swarm, like I said, hasn't been struck in at least the last several months with any kind of swarm activity. Further to the south, I think it's at this point it would probably be prudent to look up a few of the other earthquakes and show you guys where they reside in relation to the volcanoes. All the way down the coast, or I'm sorry, down the border of California, dormant volcanoes hit, and all the way down the coast, fault zones hit. So on one side we've got magma chambers, on the other side we have fault zones, and then there's just a few geothermal operations and volcanoes down to the south and to the north that are also being hit, that are mixed in, that we've talked about over and over again. We've talked about Clear Lake Volcano, Geyser Peak Volcano, how they've injected large volumes of water and are steaming that off to collect it for power generation, and it just so happens that operation is just getting slammed by earthquakes. Same with down here near Salton Sea. One of my viewers, Jenny, she's here in chat right now, the earthquake chaser, she went down to Salton Sea to investigate for us to see if there was any kind of new steaming that was occurring or anything like that. There was nothing like that going on, but she noticed the large geothermal pumping operation at the location. Then she noticed a sulfur smell, and it turns out they had issued a sulfur warning, a sulfur dioxide warning for this area 3 weeks ago, right at the same time, just a couple days before the 5.2 hit. They issued a sulfur dioxide warning for it could cause nausea, it could cause headaches, and that was from the authorities in Southern California. And they said it was due to natural processes, quote unquote, natural processes. So that all being said, let's go look up a few of these that are striking here, all the way down. We could even start up in just the small 0.4 in northwest Nevada. In the Gerlach Empire of Nevada, we'll pull the coordinates. And I always recommend you do this when you want to figure out what's going on with earthquakes. You got to go look them up. You got to see where they're striking. And I want to prove to you that they're striking at dormant volcanoes. I could tell you, but it's much better and much easier to show you. And within just a couple miles, I mean, right across the range, we've got Fly Geyser Volcanic Butte and the Calico Mountains Volcanic Center. And it goes all the way down here. Each one of these is an old butte. Now, these are also weathered on the side from wind and water erosion when this was an inland sea. So that lets you know how old they are. But you can make out the different colored igneous rock, lava rock as some people call it. But Fly Geyser, let me zoom in on this. This is a state park. Somebody apparently drilled in here and ruptured an area, and it caused a new geyser to erupt, and then it was laden with all sorts of heavy water, filled with minerals, and it formed its own new geyser. And it's a really impressive geyser that's there. Obvious hot springs. Take a look. You might not see that. If you do see it, I hope you guys can make out these pictures that are on the screen because they're really impressive. And it just kind of lets you know overall that there's something going on, geothermally speaking, at the area. And it's right next to a series of other volcanoes. And we have, in the basin of the nearby volcanic buttes, so these are all volcanic buttes, and right here at the center is where the earthquake struck. Now, it's just small. It's minor. Just a little earthquake. But the reason that matters is because you combine this with the rest of the volcanoes and geysers and geothermal locations being struck to the south, and it means overall there's pressure coming up from down below and pushing to the east-southeast. That's the direction all these earthquakes are going. We have that silent zone still around Los Angeles, which is starting to worry me because of all the activity to the north, south, and east. That means that this area here is building and should release either in a new swarm or a single larger earthquake. But that was just the first earthquake we looked up. You might say, that's just one of them, Dutch. What about down to the south? Well, let's just carry on. We can go down to the swarm, pick the largest of the swarm to the south. Northeast of Hawthorne. Okay, people say Hawthorne. Well, that's a lake, right? Lake Hawthorne. You may have heard of it, maybe not. If you're on the West Coast, you probably have heard of it. Let's go put it in on Google Earth and see what's there. Whoop. There we go. Okay. As we zoom in on the area, of course, you're going to make out Lake Hawthorne over to the west. Now, all these areas down to the south and to the north, when we zoom in, they're going to be discolored. Many of these, and they're not marked by the USGS, but they're no doubt 100% old volcanic buttes that you can even make out the leftover flows that we're seeing off the peaks of these. What is this? Indian Head Peak, for instance, being one of many that's out here in the backcountry, not labeled. And they're down near the highway as well. We have old buttes weathered over time, but there's no doubt about it. These are ancient volcanoes. And you can make out, again, you can make out the basalt, igneous rock even, but definitely basalt tops. A tuft that forms on the top of the butte, just like down at Salton Sea volcanic buttes. Only there's no sea next to this. What else do we have out here? Oh yes, this is also a military depot. So these are bunkers that contain ammunition, but the earthquakes are happening multiple kilometers below the surface. So it's just ironic that this huge military storage area where they're storing each bunker is probably filled with God knows what, but those are all bunkers. Each bunker is filled with ammo, and we have large volcanic range over to the east. You could even say that this might even be part of one single volcano at some point in the past, just with its overall shape. And when you look at the different formations that make this up, the old lava flows that make up this, and at some point in the past, this was totally covered. That these tufts on top, that this flowed out of the top of this whole mountaintop at some point in the past, ruptured like a fissure. What is this? Black Dyke Mountain. So Black Dyke Mountain at some point in the past erupted and flowed lava down the side, and that is what you're seeing right there. That fissure formed and formed a huge dike mountain. If there's any question, just to the north, you have Pilot Cone, Basalt Peak, and they look just like the same down to the south, only these are actually marked, and they're mining this one. Look at that deep pit mine. Look at how far down that goes. All right, well, anyways, there we go. Basalt Peak Volcano. Very creatively named. Pilot Cone. Pilot Cone Volcano. And again, just like the other one, you see the basalt, cracked basalt, going all the way up to the top with a tuft, letting us know that this was a previous volcano. So what does it mean? These ancient volcanoes are starting to show movement, while the magma chambers, the ancient magma chambers down below, are being perturbed. That's just the second cluster that we looked up. We can go look up these. Now, I was just talking about the frogs, and what does that mean, and the people asking about that. Well, let's go look up the largest of the bunch. Let's take the 1.5. I'm just going to systematically go down the list. We have to do this, because people came into my chat last night, and not just chat, but below my other video, and tried to say that I don't look up the earthquakes and that I'm just saying they're volcanoes. I deleted the comments because it was just ridiculousness. But I want to prove to you that there's volcanoes at or near each location. For instance, just northeast of Tahoe, where we're seeing all these earthquakes strike, and we're talking about the frogs to the northeast, and we're talking about the swarm going northwest across these buttes, Sugarloaf Butte and the Buttes Volcano. The Buttes Volcano, very creatively named again. Somebody built their house right on the... I bet they have geothermal operation there because they could keep their house warm. Certainly they could do that. But it extends in a line of other buttes that are unnamed up to Lassen, where the swarm is now occurring. But we'll take this back down, and what is it right next to? It's next to Steamboat Springs. And we can read this. Steamboat Springs, a small volcanic field of rhyolitic lava domes and flows about 20 kilometers south of Reno, Nevada, ranges in age from 2.53 to 1.14 million years. No eruptive activity has occurred at Steamboat Springs during the Holocene, although it was included in the Catalog of Active Volcanoes of the World, Coombs and Howard 1960, based upon its geothermal activity. The Steamboat Springs area is dotted with about 50 active hot springs, numerous steam vents, and fumaroles, and is an actively producing geothermal field. There we go. So they're siphoning it off for geothermal use. Now, I didn't bother to zoom in and look for it, but geothermal use. So I don't even know where the operation is, the geothermal op, but it's somewhere here, possibly as far east as Soda Lakes, but it's right there. Okay, so that's the next spot to be hit with the earthquakes. That was the 1.5 to the north. Now let's go down south. The bigger earthquake, the 2.4. This is the largest of the bunch so far, and I think I'm going to start to drive home the point by the time that we look up this next earthquake. This is in Yosemite Valley, right? Yosemite. Very famous. Everybody knows Yosemite Park. Not many earthquakes at Yosemite. Let's go see what's nearby. Okay, so back this out just a little bit. just a little bit so we can get a greater view of the area, same county. And just across the county lines, we have the edge of the Inyo craters, which comes all the way over here to Iron Mountain, which is a past volcano. Now, they say that these are not volcanoes back up in Yosemite. But if you go look up the eruptive history, they'll say that it got covered in lava, that they don't know how, that there's peaks covered in lava, and they really need to readdress. In my opinion, they need to readdress it all. But just to the east, not even a county away, we have the edge of Mammoth Mountain and Inyo craters. So the largest of the bunch striking below the cluster right next to Mono Lake. This is a supervolcano. So when you see something strike next to Yellowstone by a few miles, and West Yellowstone along the mountains, you assume it to be related to Yellowstone. Well, we would assume this to be related to Mono Lake supervolcano and Inyo craters, which is much bigger, goes all the way down here to the south, connects all the way down, goes into the Long Valley caldera, which we'll get into in a second, because when we go back and look at the earthquakes, again, we're going to be going down the coast, and that's the next stop down the list. So we just looked up the 2.4, looked up to the east, of course, that's Mammoth Mountain. I don't even have to look that up, I just showed it to you. So due east of the 2.4, let's get back over there and show it to you. Why not? Okay, there's our 2.4 location, and due east is the other swarm. Well, that puts us right at Mammoth Mountain, Inyo craters. Let's zoom in and show you the Inyo craters since there's so many. We have all sorts of old cones that are weathered down over time and covered with trees. Several newer, Deer Mountain being one. Here's an obsidian dome that's risen out. These are all volcanic in nature. These aren't just popping up randomly. You've got multiples. Here's another one. It's more impressive. What is this one called? This one's called Obsidian Dome. So Obsidian Dome is an obsidian dome. Go figure. Wilson Butte is another one. And they just go on for miles. Many hundred more. And some of them are weathered. Some of them are a little harder to make out. It's on the edge of a hot springs. And then we go right down into Bishop, Crater Mountain, Red Mountain Volcanic Butte, Charlie's Butte Volcano. Pretty interesting stuff, right? So when we have all the earthquakes striking here, let's go compare it again so you guys can see that I'm not exaggerating. They reach all the way down through this valley right here to the north part of the valley. Then it skips over and goes right down to the southern portion of the valley. You see that? Let me zoom in a little bit here. The 0.9, 0.6, 1.0. See where these are down here at the southern tip of this valley? Let's go down to the southern tip of that valley and show you what's there. So here's the valley. Let's come down to the southern tip, and it comes right out here. And what do we have? We have Volcano Peak. These are lava flows. Old lava flows, but not too old. Still fairly young, not weathered. And more buttes, more large lava flows extending far out into the desert. Goes down into China Lake, the famous China Lake. And that's not the only one. If you see this as part of the Coso volcanic field, we have more obsidian domes, large deposits of obsidian rock, basalt, and it looks like black volcanic igneous rock of some kind. And we'll back this out, show it to you overall where it is in California, and we're going down eastern California along the border. Now let's get a little bit more specific. Okay, we just got down there. Would you like to go see what's over to the east, where these small microquakes are occurring? This is really interesting. I think you guys will probably be interested to see what's there. Let's go put it in. And I'll explain why we're looking all these up in a minute. I mean, I really want you guys to get a picture of where each one of these is occurring and why they're occurring there. Okay, small microquake. Where did it strike? Skull Mountain Volcanic Buttes. Just like all the others, at some point in the past, the whole top of this mountain ripped open, or lava pressed up along in a fissure and flowed out the top and over the sides. I just want you to think about what that means. Now, what does that mean? Well, it means at some point in the past, all of these locations did the same thing, and they happened for a long time. This ties in with something that the professionals just released, a news story that just appeared in the news, confirming from Stanford, also from Arizona State University, telling us that the core of the Earth has a new, they've identified two new blobs. They call it large blobs of some kind of unknown material coming up from the core of the Earth. and that it comes up like a lava lamp towards the surface, towards the crust, and that when it does, whatever this stuff is causes eruptions to occur for thousands of years at a time over hundreds of different volcanoes at once. And that's a new breaking discovery. They say that that's happened in the past. Well, that explains all of our hundreds of volcanoes and how they're all relatively the same age. That the last time that the plasma core of the Earth upwelled close to the crust, that it caused thousands of volcanoes to erupt all at the same time or thereabouts within a few hundred years of each other, or a few thousand at the most. That's insane, but there it is. Now, why are they readdressing the core of the Earth and what it's made of? Anybody got a guess as to why the professionals are all of a sudden addressing the core of the Earth? Well, it's because it's been being talked about everywhere. So far, I've taken you all the way down the coast or at least along the border of the coast, and all of these earthquakes over to the west are fault zone. You feel free to go look them up. We got San Francisco. We're going right down the coast. There's nothing there. I went and looked them up over the past day and a half. There's nothing interesting there. No kind of pumping operations. It's strictly fault zone movement. But at the north tip of the fault zone movement, you have Clear Lake Volcano and Geyser Peak, which we've shown over and over again in many past videos. I don't want to bore you with showing that again now. But that's a geothermal pumping operation, just like what we were looking at over to the east by Steamboat Springs. Further to the south, we get into Los Angeles, South Los Angeles, and going into Salton Sea Volcanic Buttes. And this is the location where the magma chamber is still rising. It's rising as of right now. This is the past 24 hours of earthquakes, 0.0 and greater, proof that the whole area around Salton Sea is still active, something's going on, and it's most likely rising. We thought 2-3 weeks ago it may fizzle out. It has not fizzled out. It is carrying on. This is highly abnormal. Any professional will tell you this. We've already seen well over 3,000 to 4,000 different earthquakes strike this location since the 5.2 struck, which just kicked it all off. It's not a result of the 5.2. You do not see 4,000 smaller quote-unquote aftershocks coming off of a 5.2. That the 5.2 was the first spot where it broke as the pressure's upwelling from down below. So now that I've reviewed just basically all the different volcanic locations that have been hit, we don't have any pumping operations showing activity right now, no oil and gas pumping operations at all, just fault zone movement and magma chamber movement. This results after the movement up off the coast, the 4.3. Let me turn that on so you can see it. Here we go. This is the last, just over the last 24 hours of larger earthquakes. And then you see the 4.3. You don't see any of the smaller earthquakes, okay? So you can see, though, that the 4.3 struck, the 3.1 halfway in between, all the way down to South Utah was struck, and all the way over to the Midwest at the New Madrid seismic zone. This is the last 36 hours. Here is the last 48. So if you live in the United States, after I run over all that, what does it all mean? Well, the reason all those volcanoes are moving, the reason the fault zones are moving right now, is because there's upwelling pressure coming from down below the west coast, offshore, where the 4.3 you see on the map here is now. Pressure is coming up from down below there and pushing to the east-southeast. And it's causing earthquakes all along the way as far east as the Midwest. And so over the next few days, it's going to cause additional earthquakes to strike down to the east-southeast. Now that the 4.3 struck here, it will push down to the east-southeast and cause additional movement in Southern California in the silent zone that hasn't been hit yet. And we just showed it. It's all around Los Angeles. We've got swarms kicking up at all the different dormant volcanoes, letting us know the magma chambers are being perturbed from underneath. So this is now go time. In the next couple days, we should see that Southern California movement. After that, or during that time, to the east, in areas that we wouldn't normally expect larger movement, this could go into Utah, near the UN Carret volcanic fields at North Arizona, also southern Colorado at the fracking operations, West Texas, curling around up through Dallas and going up into Oklahoma and Kansas. This is the next stop. Could go as far, I didn't mention Yellowstone. Again, everybody talks about Yellowstone, so kind of, driving home the point on Yellowstone is kind of foolish. But Yellowstone showing movement, again, the magma chamber perturbed from down below, just like all the other locations. Further south, there's another 3.4 that struck at the fracking operation in South Wyoming, and the fracking operations Oklahoma, Kansas already struck. And the reason they've already been struck is because of the pressure last week. So this week, the same states have to watch for the same movement, and it strikes every week after we see movement off the coast. Now, if you're on the East Coast and you're just now tuning in, or you don't normally pay attention to earthquakes, you have to pay attention to earthquakes in the Midwest. That will determine your activity in the East Coast, going up to New England and Southeast Canada. Now, speaking of Canada and everything else that was going on with yesterday's update and the information that we went over, the sulfur dioxide plume, no one has an explanation for. I waited a full 24 hours from professionals. If you don't know what I'm talking about, let me take you over and show you. It would be best. Picture speaks 1,000 words, so we'll just go ahead and show you. We go to earth.nullschool.net, and we're going to turn on the sulfur dioxide feed. You do that by clicking on Chem and then clicking on SO2. This will show us all the sulfur dioxide, a byproduct of fossil fuels and volcanism. So when we look at an area and we see a large plume of sulfur dioxide, we have to question what's producing that plume. And normally, if you see it around a city like New York, you would expect it to be pollution from cars and industry. But if you see it out in somewhere where it's very rural and there's nothing going on out there, then that means sulfur dioxide is either coming from burning petroleum products of some kind naturally or a volcano of some kind. So when you see up here in Canada, you have a large sulfur dioxide plume appearing south of Lake Athabasca, and another sulfur dioxide plume even further north, you start to wonder what's going on there, and the other locations to the south. Now we find out there's a wildfire going on there, and we might see some carbon monoxide associated with a wildfire, but there's none too big. As a matter of fact, you can see the carbon monoxide is not that great. Look at New York now compared to the carbon monoxide up here from this supposedly huge wildfire. Well, when I turn on CO2, carbon dioxide, I want you to take a look. You see how it's kind of white there? Maybe I should zoom in a little bit so you can get a better picture on this. See how it's slightly whitish there? Now I'm going to take you back in time, and we're going to go back just a day. We'll go back a few hours. We'll go back hour by hour. And when I start to see what comes into frame here, I will stop it to draw your attention to it. Now you might already see through the screen that it's already showing. See how it's a darker white or a thicker white? We're going to keep going back. See, there's blue center on that. See that? That's a large belch of CO2, carbon dioxide. Now, fires do not emit carbon dioxide normally, unless there's something strange going on at the location with CO2 storage. But it's not. The location itself is a giant dome 230 miles across and rising about 500 feet towards the center of the dome. So when we look at the area, you see heavy CO2, heavy SO2, and moderate, or well, at least this is last night. This is when they said it was a wildfire. But I would challenge the notion of a wildfire because a wildfire does not produce sulfur dioxide or carbon dioxide. So the source of carbon dioxide and sulfur dioxide is either burning petroleum products or magmatic sources like lava erupting or a volcano belching off gases from a magma chamber down below. And those are the two options. And when we go look at the area, let's go show you. Okay, we'll take this up to Canada and we'll zoom in on the area. And I showed this last night, but hopefully you guys will be able to see it again now. That this circular formation forming Lake Athabasca goes all the way down here to the south, and we cross-sectioned it last night, but I think I'll just do that again for you now. From the edge of Lake Athabasca, we rise from 1,000 feet up to the center, which takes us up to 1,700 feet, and then it goes back down to 1,000 feet on this side, right where this circular formation is. And I'll show you the circular. I mean, it's undeniable. It really is. It comes off of Lake Athabasca, and this is not from erosion. This rises. This is a rise. This is a dome. This is a giant dome, and we can follow it down around, and then you see it makes a bend up and starts coming up this way, right? And you'd say, okay, it just keeps on going. Nope, it stops there, and it goes, bends. You follow the ridge back over, too, and so you have a large dome-shaped structure this big, And out of the center, somewhere near the center, somewhere right in here, we're seeing this large emission of CO2, SO2, and wildfires breaking out. So either this dome is filled with oil, that's a possibility, that we're looking at large deposits of oil shallow in the ground, that if a wildfire does come through, the wildfire hits the oil deposit burns, puts off CO2, which you would expect from burning petroleum products, and it puts off SO2. And it's coming from here. There is no mining operation here. There is nothing there that could be causing that except for the giant dome itself releasing some kind of sulfur dioxide gas. Furthermore, to the north at the Great Slave Lake is where the other plume is coming from right in here. And when you look at this, it's the same thing. 230 miles across. Let's zoom in and show you. Oh, wait a second. Let me turn this off. Okay, 230 miles across down to Lake Athabasca. So same size, and it's the same shape. So see the oval formation here goes down around, comes back up, goes back up around. All right, well, the sulfur dioxide, carbon dioxide, and carbon monoxide are all still showing up today in slightly lesser amounts at both locations. So that's the update on it. What's causing it? I don't know. I do know that wildfires do not produce sulfur dioxide or huge bursts of CO2, belches of CO2, like what we're seeing. Now, a viewer sent me something about CO2 storage and said, hey, maybe they're doing clandestine CO2 storage sequestration. In case you guys don't know, there was a huge climate change debate a few months ago, or now a year ago, where the U.S. met up with a bunch of other countries and they were talking about what they should do about climate change. And one of the geoengineers' ideas, and there are geoengineers, was to do CO2 sequestration in old oil wells, or to drill new wells and pump in CO2, or dump in CO2, liquid CO2, where they condense CO2 out of the air and condense it down into a liquid, and then they take that liquid CO2 and put it into the ground and store it forever in the ground as like a giant soda can, only worse. It's liquid CO2. So, and they did that in Colorado, by the way. Now, they could be doing that there. I didn't see anything there that looks like that, though. But they did that down in Colorado, in western Colorado, in Colbrand. And you guys may remember the name Colbrand because there was this giant upwelling of liquid sand mixed with CO2 that came blasting out of the ground in western Colorado. And it put a multiple mile-long landslide down a mountainside. And they tried to blame it on a tiny little lake that was at top, and 3 people were killed. But it was a CO2 sequestration operation that blew. And there was liquid sand down in there with liquid CO2, and it all came erupting out at once out of the side of a mountain, like shaking up a soda can, and it, and then puncturing it at the top, and it goes, psh. Well, the same thing happened on a mountain scale, and that was a CO2 operation there. So, could we be seeing CO2 blasts coming off from this giant dome shape? It could be a volcano. It could just be a bulge in the plate, but whatever it is, it's circular formation, 230 miles across, and the one to the north, 230 miles across, both of them giving off CO2 and SO2. It's suspect, to say the least. And anytime I see something like that happen, I've got to raise the question and make you guys aware of it, and we just have to watch it. It's still going on now. So whether or not, it's a fire or whatever, something else is burning that's causing that CO2 and SO2 to show up. So that's the U.S. update. You have to be prepared. We're watching again for 4.0 activity, maybe even 5, to strike in Southern California, and we're watching for moderate movement in the 3 to 4 range to strike across the Midwest over the next few days. East Coast, 1 magnitude less. So you see the 3.5s, you have to watch for 2.5. So moderate, light activity to the east. Not a big deal, but it's something you do need to watch out for in case something larger strikes. You'll always have at least a day's warning for larger movement on the East Coast, because we always move on the East Coast after we move in the Midwest and on the West Coast. And the same holds true for Central America and South America. You always move to the West first before you move over to the East. And as you can see on the map here now, we're not seeing much activity striking in Central America over the past day. Instead, we saw a new volcanic eruption at Popo, and we saw some new activity down here to the south near Ecuador, but it went silent over the last day. Silence in earthquake-prone areas is not good, as many of my viewers know. Now let's quickly get into the international activity, and we'll go ahead and call this out. I'm going to turn back on, let's get the display capture off, and let's just see how many people are in here before we go any further. I like to know just how many people I'm reaching. It looks like about 400 people in the chat room tonight. Really cool. Thanks for everybody getting the word out on this, by the way. So internationally speaking, where do we watch, and what kind of magnitudes do we have to watch out for? Well, the international magnitudes are based upon the deep earthquakes that happen around the Pacific. And we were waiting for new deep earthquakes to strike as of my last update. Right after the update, the USGS threw an earthquake on there that happened yesterday or the day before. So you can see these earthquakes raised high off the globe. This is an earthquake 3D feature to show us the depth of earthquakes. So we were waiting for this to happen, and now it has. And we saw a deep 4.9, that's the larger earthquake on the right-hand side or to the east. And to the west, on the left-hand side, we have a 4.5, both happening down below the plate. Since then, we've seen one earthquake strike directly in between the two deep earthquake spots to the east and west, and that put us right down in the middle of Solomon Sea, Solomon Islands, east of Papua New Guinea. That's this earthquake right here, the 4.9. Again, my mouse doesn't match up for you right now. But overall, when we look at the activity that should strike, we have to look for 1 to 2 magnitudes larger than the deep movement. So we have a deep 4.9 on one side to the east, and we have a deep 4.5 on the other, and we're looking for 1 to 2 magnitudes larger, which takes us up into the mid 6.0 range to strike in a nearby silent area in the next day to 2 days at the most. And when you look at the nearby silent areas, well, the 4.9, that's one smaller earthquake, that's similar size earthquake, but it's not what we would expect to see to relieve the pressure. And the area to the west, Sumatra, let's turn this down for a few more days. Here's 7 days earthquake activity. And do you see anything missing from over at the tip where these 2 points come together? Of course, we're missing earthquakes here at Sumatra, also going into Malaysia and the western Philippines. But this point here along Sumatra where the 4.4 is on the map, let me highlight it so you can see what I'm talking about. There, that earthquake there, that spot is a spot where we should see larger movement strike when you look at all the other activity that struck over the last 7 days, 4.0 and greater. And a lot of people say, 4.0 and greater. They're not, those are smaller earthquakes. Let's look at the 5s and greater. A couple of them, 4.9s downgraded, so let's keep those on there. There we go. Now you can still see heavy activity all across the West Pacific, but nothing in Sumatra at all going into Philippines and South Indonesia. That means there should be compensation movement there in the next few days, and it should be rather large. Again, when you look at all the activity, it stands out as a silent spot. And silence in earthquake-prone areas is not good. Now, in the forecasting, we look at the last 48 hours. We look at the last 48 hours of earthquakes. This will help us to determine magnitudes. So if you want to get an idea of what magnitude to expect over here, we have to look at the most recent earthquakes. Now look what struck to the east, the 4.5, correct? So we have a deep earthquake right there. A series of other 4s fanning out all the way from Japan, the 4.8 to the north. Let me highlight that. And the 4.9 all the way to the south at Solomon Sea. Well, all those 4s combined with 1.5 on the Izu Ridge means that there should be at least 1 magnitude larger than all this movement combined. Well, if you add them all up, you have to earthquakes go up by order of magnitude by order of 100. So, by a factor of 100, I'm sorry. So, we're talking about it would take a lot of these earthquakes to equal 1 magnitude larger. And I'm looking at, most likely, the 6.5 to strike in the silent zone in the next few days, adjacent to all this movement to the east. So it nails down the area pretty small, and it most likely will strike right along our progression zone. This progresses up to Asia, going into North India, Nepal, that we see lateral movement to the west-northwest off of all the movement from the Pacific. So the silent zone, it stands out. There's additional silent zone in the far northwest Pacific, and let me turn on the ring so you can see a little better. Now, yesterday we named out near Tokyo as a spot to watch, and the area just west of Tokyo was hit. We have Tokyo right in here. Just west of Tokyo was hit. But now, the only silent zone that is left to be hit is Hokkaido. And Hokkaido, north of the Izu Ridge, Here's our spot where the megaquake occurred. Let's zoom this in. Okay, again, my mouse is not matching up, so just understand where Japan is and our megaquake location right along the eastern coast of Japan. Where the 4.4 is, just north of there is where the 9.0 struck back in 2011. And that's the silent zone, going north to the North Island of Hokkaido, which is the North Island in Japan overall. So that's the silent zone, and the magnitude to watch for, like we said last night, 1 magnitude larger, not 2, 1. The reason we say 1, we've only seen shallow earthquakes here so far. If a new deep earthquake happens here, then that takes us up by another magnitude. But right now, just for adjacent lateral movement at that shallow depth, and it'll be similar to 1 magnitude larger than the largest of the bunch we see here now, at least with the 4s going along Japan, and that takes us up into mid-5. So for people in Japan, they're not that, they're not that blown away by a 5.0 earthquake. Like people in California would absolutely freak if a 5 strikes in Los Angeles, but in Tokyo, when a 5 strikes, they kind of just go, ish, and walk away. So silent spots to watch. Hope you guys understand why we watch them and what magnitudes to watch out for. So deep earthquakes, 1 to 2 magnitudes larger. And for the adjacent shallower movement, just 1 magnitude larger. And it always hits the nearby silent zone, and it always hits within a couple days or less. And then the progression of earthquakes, that's the next thing you watch out for. Once we see the movement happen, it progresses across the plates to other locations around the planet. In the United States, it progresses across the plate from the west coast to the east coast. In Central America, it progresses from the west coast of Central America to Puerto Rico. In South America, it progresses from the west coast of South America down south to the South Sandwich Islands. Ultimately, they all press, the North, Central, and South American plates press to the mid-Atlantic and release over here with a few single earthquakes. Whatever's not expended as it presses across the plates gets left over there to the east. In the West Pacific, it's the exact opposite. It goes from the West Pacific all the way over to Europe. And you can see the connecting lines here, but for a better view, let me turn on the combined USGS and EMSC feed. This will show us the last 7 days of USGS and the last 50 EMSC recorded earthquakes. And the EMSC earthquakes should all show up pretty much white since they're most recent. So the last week's activity, heavy in the West Pacific, spilling across the Mideast with our huge cluster spot north of Kazakhstan and in south of Russia, west of China, northwest of Nepal. So right at that border region. But then to the west, we saw earthquakes spread out across South Mediterranean, going as far west as the Mid-Atlantic Ridge. Check it out. And the earthquakes always progress across Europe over to the North Mid-Atlantic and release here to the North Pole. The U.S. earthquakes progress to the Mid-Atlantic and progress from the, I don't even know what location that is. I guess it's Barbados, east of Puerto Rico. It progresses all the way over to the fracture zones. And we've got hundreds of fracture zones. So naming one is kind of hard. But, the Panache fracture zone, for instance, it's like, what, Panache, really? But you have all these different named fracture zones for each different east and west facing line on the screen is a different named fracture zone. And it strikes all up and down the Mid-Atlantic Ridge after movement comes from the United States and after movement comes from Europe. And you can see the progression now. The earthquakes progressed across Asia, went down into Iran with 5.0, 4.8. These are striking near volcanoes in Iran, in case you don't know there's volcanoes there. Really interesting plate structure in that location. But then pressing on Turkey on both sides. Both sides of Turkey at the border moving to the Black Sea. Here's the Black Sea. Here's the Caspian Sea. All of Turkey moved this past week. You guys saw it happen live on the live stream and kept talking about it. Well, it pressed to the north-northwest, and look what happened. It caused that 3.6 in Italy that you don't see anymore because they removed it. Then it caused all the earthquakes in Switzerland. Then Spain was struck. Then France was struck. The next stop is going to either be the Azores or the Mid-Atlantic Ridge. West-northwest out to the Mid-Atlantic. I would like to also show you the British Geological Survey feed. British don't share their information. You actually have to go get their little feed for this many earthquakes, right? So take a look at it, though. Look to the north. See this? See the 3.2 striking out here? That's a fracking operation that they build some platforms out there to do this massive gas extraction You can't get it on, there's no satellite view. It's just open ocean, but that's what's there. And now we're seeing threes strike there all of a sudden over the past several weeks. Well, the threes striking there tie in with the threes that struck to the south that I just showed you. Again, that pressure transfer going across Europe comes across the English Channel, goes up right across, out to the mid-Atlantic. This is Iceland up here. Iceland showing all the eruption threat at Hekla and Bartabunga getting hit by a new swarm. Ultimately, sometimes we see near Mount Dutch supervolcano at the far tip of the North Mid-Atlantic Ridge below the North Pole, and the Gackle Ridge right here at the bend. Those show swarms after we see Europe move like what we're seeing right now. So Europe, you have a silent spot to watch. Let's get back over and show you. I know I don't have many viewers there, but it's worthwhile to show you guys overall. You have a silent spot between the two spots that have moved, and this puts us back down into central Italy between the 2 points. Where does that put us to? It puts us to Rome, east of Rome. So it's a pretty small spot inside of Italy to watch. I'd be more leaning towards central Italy as opposed to north. Of course, Switzerland and CERN and all the operations there with the beam drops and the energy precipitation that goes down into the crust. We have to watch Switzerland as well. Seems that Switzerland keeps getting hit over and over again, and all the areas around Switzerland keep getting hit over and over again every time they do their major beam drops from CERN. You know, trillions of electron volts going to ground. It's amazing. So that's kind of a recap. I think most, don't really have much else to discuss when we're looking at the silent zones. The only area I really didn't discuss in depth this time is South America. And the South American coast is a spot where we almost have to turn. Let's check the USGS feed, see if that's going to show it. It just shows the 14.6. Let's check the last 7-day feed, see if that shows anything better. Okay. Actually, it does. Okay, this is great. We were watching for the coast of Peru into Ecuador to get struck. And we were watching for the northern bend at Chile to be struck. Additionally, after all that, we were watching for movement to strike down the coast, reaching down towards the South Sandwich Islands. Well, Ecuador was struck. The bend at Chile was struck. The earthquakes have struck down the coast. The only spot that hasn't moved yet is our silent zone here off the coast of Peru. And that's really interesting. But if we go down a few more days, this is the last 48 hours. Take it down a couple more. Then you'll see the coast of Peru got struck right in the middle. But it wasn't what I was expecting. So that means it's still building. And you don't go 7 days at a location without an earthquake in the Pacific that's normally prone without seeing some kind of compensation movement eventually. So, it's just building there, and we have to watch. We have to continue to watch because it will get struck. And when it gets struck, it should be larger as opposed to smaller. And just as I'm talking here, another 5.0 has struck in South Iran. And at this point, let's just go ahead and go show you what's there. I think this might be the best way to end the video. We'll end it with Iran. Let's turn on my display capture for you to see on a full screen. We'll go over to Google Earth and put it in. All right, and this is going to take us halfway around the world. In on the 5.0 location. Nothing too interesting right there. We'll back it out, and then you're going to see some interesting formations here. All right. Now, look what's right here. Do you see this? Now, I already looked this up last night, but I didn't bother showing anybody because, it was getting kind of late, and we were already doing a bunch of else. But these are obvious domes, lava domes, and this is just a smaller version of what we were looking at up in Canada, basically. Let's get a measurement on this. It's just a few miles across. I mean, the Canadian location is about 230 miles across, so this is 1/100th of the size of the one in Canada, but it's the same formation and same striations and the same shape that you would expect to see on any kind of lava dome rise. And if that was the only one, you might say, oh, Dutch, okay, that's not, there's nothing to worry about there. It's not the threat of a new volcano. But there's other nearby domes that are similar. So that's, we can go down to the south and you can see you've got one here. Check it out. Look how this one's float over the top of the mountain. Remember how I told you over in the United States that those mountains split on their tops and flowed out rock over the tops of the fissures as the pressure came up? Well, this has happened here as well, and that's what you're looking at on the screen right now. This is just another I mean, you can make it out. You can make out the nature of the rock, the igneous rock, the basalt, the past lava flows that are associated with that. And it goes all the way down to the coast where you have more. These are really impressive too. Looks like we got a little mining operation going on out here. Ah, a geothermal operation. Check it out. Look. Geothermal pump right there. Geotherms. All right. Right at the center. Got a geothermal pump. Right at the center, you got a geothermal pumping operation. To the west, got another one. So at some point in the past, these split open and just emit a large amount of lava, and it goes, they're on every single range. Every single one has another one. Similar. Very impressive looking. I mean, look at this, guys. Do you think that lava rock? All right. So that's where the 5.0s are striking. And again, they're related to volcanism. And look at the plate tectonics overall. Look at the way that their craton bends. This comes off of the Himalayan range. And look at that. Look at the bend in the plate. Is there any wonder why there's new lava or huge lava domes forming out here? The whole thing is speckled with them as far, way off in the distance. Here's another large one. This one even has a center dome at the dome. So it's a dome within a dome. And you can make out the flows on this. This had to be very impressive when it did erupt in the past. You might call those Mar volcanoes. All right, well, has it become informative enough for you? Has this been a great update or what? Guys, I love doing this stuff, and you know why I do it? It's so that I can get the word out on earthquake awareness from a perspective that you'll never hear from any professionals. So I hope that sums it up. Now you know what to watch for internationally. In Europe, I didn't name the magnitudes to watch in Europe. In Europe, we need to watch for the magnitudes nearest the largest of the bunch. So we don't have any new deep earthquakes to base it upon. So when you look at the earthquakes which struck on either side, let's quickly do that and wrap this up because it's getting way long. We have 3s to the east, 3s and 4s to the west. This puts us in between 3 and 4 for movement to strike right between the 2 points that have already moved. Additionally, we have to watch for 4.0 activity to redevelop out here along the mid-Atlantic, going south as far south as the Azores and Canaries, but most likely on the mid-Atlantic going north. But our southern cutoff point for Europe and the pressure transfer is near the Azores, sometimes is along the coast of Portugal. But again, watch out for that 3 to 4.0 activity. It's not that big, but when it strikes in Rome, it always makes the news, or at least some kind of little blurb headline. How many people are in here? 378 still? Awesome. Good to see everybody in the chat room. There's a group called the Dutch Squad Earthquake Group, and they'll post a link in here where you guys, if you want to join, you're into geophysics, you want to talk with other people who are, there's a Facebook group set up for that. And that was created by them. I have no hand in the matter in the creation of it. I am a member myself. I don't post there that much. I just do a lot of reading, which I recommend you guys do too. And if you do have something to say, I've got a question and answer page set up on my Facebook page, where if you have a question you want to ask me, I will try to answer it in my nightly question and answer sessions that I do after this live update. So I always wait about an hour, sometimes 2 hours. It just depends on how chill my wife is and everything. And I answer the questions, as many as I can, within an hour or two's time. And I usually push it till about 2 a.m., 3 a.m. Central Time, and just kind of interact with everybody in the chat room. So if you guys are curious about anything that we're talking about here, you can ask me tonight, or you can put it down in writing and get a hold of me that way. I will be back in. For those of you who do not have an earthquake plan, let me just tell you something. You need an earthquake plan. You just need to know what to do in case an earthquake strikes. You need to look at your building, your surroundings, know your area, know what magnitudes are coming. So, on the East Coast, are you going to worry about a 9.0 earthquake? No, not right now. But on the West Coast, are you going to worry about a 5.0 earthquake? Well, it might be a good idea to just, batten down the hatches and make sure that the stuff that's on your shelves might not fall off and break in the middle of the night. You may remember the 5.2 struck 3 weeks ago in the middle of the night. It was, 1:30 in the morning? And big earthquake strikes for the area, shakes everybody up, and I guarantee you there was some stuff in people's houses that was broke. Well, in the middle of the night, do you sleep with your shoes on? Do you have your shoes right by your bed ready to grab at a moment's notice? You think that you may need that? I wouldn't, unless you start thinking about an earthquake. And then you think about glass across the floor and you running for cover. You might want to have shoes set up in a bag all ready to go, with socks, packed up in a little thing with an extra set of keys, just put off to the side. We call it a bug out bag, but it's just something that you grab in case of emergency. It's got all the necessities in it. A change of clothes, maybe a cell phone battery, a little charger, some stuff that would help you if you need to grab it and get out. You still need to be mobile, but still need to be in touch. Think about these things now and go around the inside of your house. Look at your TVs and the stuff that's on the walls and shelves. Think about how you might want to secure them. Things that are on your shelves can be secured for an earthquake by sticky pads. I've seen this before. People in Japan, when the 9.0 hit, there was one guy who had a whole bunch of his stuff sticky padded, where he just had his vases and stuff with a sticky pad on the bottom. And you can tell the stuff that was sticky padded versus not, because all the other stuff's knocked over and his sticky padded stuff was still standing. And it didn't ruin the vases or anything. It was just a little thing that you put on the bottom with that double-sided sticky tape, and it was sticking that stuff on. Or your stuff that's on your walls. Think about the heavy stuff on the walls. How do you secure it a little bit more? And if you live in California, you got to think about your flat screen. You got to think about your refrigerator sliding out. Or stove. You got to think about your gas lines. If you live in the Midwest, a 4.3 struck at the start of 2016, and it knocked chimneys down and knocked facades off the front of houses in Oklahoma. Well, you got to know what to do. You got to have insurance to cover that stuff, first of all, and most insurance doesn't cover. Did you know this? Most insurance doesn't cover earthquake damage at all. You have to have separate earthquake insurance. Isn't that wild? So think about those things. What will you do? And it's always good to have a plan. You may never have to use it. It's like a tornado. You may never have to use that severe weather plan, but you have a good idea where you're going to run if a tornado hits, right? Like if a tornado comes, you know you're going to try and find that deepest point in your house. You're going to have already thought about it enough to where you're not going to be like, gee, where do I go? I don't know. No, you're going to run right to that spot. And that's the same thing to do with the earthquake. So it's nothing to panic over. You don't have to have those huge stockpiles of food and water and an automatic gun and all that. You don't need it. You don't need that. It's good to have that stuff, but to survive, you need to be able to survive the initial disaster. The water and food and all that other stuff is what you would do for prepping so that you aren't left scrounging. There are ways to survive, but you don't want to be left with those trying to compete for resources with a bunch of other people. And that's where the prepping comes in, and all, everybody gives it a hard time with the stockpiling of food and water, but there are certain scenarios where you do need a long time of food and water. I would say in California, with the summer the way it is, that you would probably want some water just because if a disaster does strike and the pipelines are busted, if a large earthquake strikes between Los Angeles and the aquifer source, breaks the water line, well, guess what? You're going to be without water at a time where it's super, super hot. You'll be left begging for Big Brother to give you some water. So you better just avoid that situation. You could stockpile water. That would be a good reason to, in California, or an area where it's arid or dry. And here in Missouri, we've got so much water. We've got rivers and lakes and everything. We will not be hurting for water here in Missouri. But it's a different situation for everybody. So it's, again, something you have to plan for. And this is why I do what I do, so you know what to expect, so you're not guessing as to whether or not it's going to be a large earthquake or a small earthquake. Right now, we're just looking for 4 to 5 on the West Coast. So it's something to prepare for a shakeup, but nothing too huge. If it changes throughout the week, I'll do my updates every night to bring you up to date on the situation, make you aware of what's going on. Other than that, that's all I got, guys. Could you please share it? Could you please share this and get it out to the world, the live stream? I'm not begging, but I would really appreciate it if you could just let people know there's a guy who's forecasting earthquakes. He's nailing it spot on. I nailed the 4.3 off the coast yesterday. I nailed the 5.2 at Los Angeles, Salton Sea 3 weeks ago. We're nailing the earthquake forecast down really good. I'm not bragging, I just got to let you know so that you know to tell other people that they can get an earthquake forecast now, that the professionals aren't doing it, and that a guy on YouTube is. That alone right there, it's kind of a freak factor to tune in, but I appreciate everybody who's helped, Everybody who's in the chat room, guys, I'll be back in an hour to do a Q&A. If you've got a question, you can answer it, or you can ask it over on my Facebook page, and I will try to answer it. Probably getting backed up on the questions. I might not get to all of them tonight, but... So, anyways, that's all she wrote, guys. Share. Much love. Much love to the Dutch Squad and to all the people. Corey, Jenny, Sunshine, Michael. I'm just reading names in here, but William Williams, RW, just everybody that I see. I want to thank you all for being here and being part of this. You got to see big discoveries be made real time on the live stream. And if you wonder, I'm going to do this right now just so I can tell you. Down below the video, I say this every night, I'm going to say it again. There's the share button, which I just told you I'd appreciate it if you could retweet or whatever. But next to the share button, there's the more button with 3 dots. You guys click on that and then click on statistics. And as of July 4th, 2 days ago, we broke 300,000 views on this live stream for the last, since June 1st. So a month and 5 days, 1 month and 5 days, we reached 300,000 people on this live stream. Isn't that wild? To me, that's amazing. We've reached 300,000 people on the live stream. It doesn't, you never really realize it. When it's, we look at the count here, it says 352. Well, that's every minute, and then every hour, it's going, 100 to 200 to 50 to 60 or whatever. That's per minute. It's amazing. I just never knew that that people would be that concerned with earthquakes. But I also think that people are liking the fact that they can interact with each other about geophysics and earthquakes. People like having other people to talk to about it, real time. So when something's going down, people like to have multiple eyes on a situation and multiple ears listening. So I'm starting to realize that it's the chat room itself is serving a function that I never imagined it to serve. And it's awesome. It really is. Oh, you know what? Just as I'm talking here now, a 3.1 has struck back in East Europe. Huh, interesting. All right. So much love, guys. I'll be back.